multi-structure, utility, reduction, all this. So the intro is much harder than this. So this one is quite okay. From here onwards, they will be better. Okay, let's look at utility theory. Now, I think all of you understand this thing called utility, right? In fact, you have done so much budget line and all this, and it's other than ME. Right, the budget line in people is one you have to reconstruct all your budget line, right? For ME, really is just you have to do all that. You also don't have the costing, you don't need all those models and materials. So it's just a very basic A-level start. So first, consumer theory about utility, right? So what do you understand about utility? Utility is used to measure what? So we have done a lot of this thing called utility. So, right. Now, first, utility is used to measure what? Utility is used to is a measurement of what? Satisfaction, welfare, right? Benefits. So utility is used to measure your welfare and satisfaction. Now, when you study utility, what does it mean if the utility is higher? It means if your utility is 1, and so if my utility is equal to 1, and the utility is 1 million, what does that mean? Alright, so my utility is 1, your utility is 1 million. So what does that mean? You are 1 million times more satisfied than me. Is that true? If my utility is 1 and yours is 1 million. So we got, I thought, the screen. You are 1 million times more satisfied than me, right? Does that mean this? It means nothing. Right? Because the number itself has no meaning at all. The number is only for ranking that your utility is higher than mine as well. Right? The size itself has no meaning. It doesn't mean that you are so much more time more satisfied. Right? It's not that your utility is finite. It's still the same. It's just that you are more satisfied than me. Right? Okay? You did not suffer from infinite satisfaction. You did not suffer, you did not derive infinite satisfaction. Okay, so it's only for ranking purposes. So what we are doing is all the while ordinary utility. Mainly just to rank you. Right? The bigger the utility, that means this person is more better off than the other person. Okay? The level of satisfaction is not important. Now, first thing, let's look at this utility here. Maybe I don't look at this. Fast forward to this. I will come back to this. Now, in our intro report, the utility function that we look at, I think all the while, something like this, right? This curve, convex to the origin. Right? So throughout our intro report, the utility function is this way. Convex to the origin. Now, the reason why, because in intro, we assume that the two things, namely group Y and group X, they are imperfect substitute. Okay? So all the while we draw the utility curve this way. Now, but if the two things are perfect substitute, so if they are imperfect substitute, so the utility curve is convex to the origin. Okay? Now, if the two things are not perfect substitute, if they are not imperfect substitute, if they are perfect substitute, then the utility curve will be a straight line. Okay? Now, the features of the utility curve are still the same. they're all parallel to each other. And you also know those utility curves that are further out represent higher utility. Right. The reason why is because the utility increases with more x and more y. And so those that are further out, more x and more y, right? That's why more utility. Okay? Now, for perfect substitute, which of course that's why we don't know that this sort of thing. Because in this world, there got such thing as perfect substitute. One. So it's very rare. Hope and Bessie, they are the closest substitute. But are they perfect substitute? No, right? Hope still have more bubble than Bessie. If you look at count, slightly more bubble. So there's no perfect substitute for this one. If your girlfriend run away, can you find another one that looks like your girlfriend? Cannot. Right? No such thing as perfectly substitutable. Even if you found one with the same look, still not perfect. Right? The smell different. The internal beauty is also different. Right? The external beauty might be the same, but internally the beauty is not the same. So there's no such thing. That's why we hardly look at this. Okay? Now, if a utility function is this, that means in mathematics, it's a straight line. Right? It's a linear function. Now, if that's the case, if you have a utility function like this, where will be the optimal solution? Now, if it's convex, it's always found at the point of tangency, right? If it's like this, where's the optimal solution? Now, to find the optimal solution, we have to bring in this thing called the budget line. Right? Okay, still recall what's the budget line? What's the budget line? Okay, this because they have learned in intro, so I didn't go through that line, but if you talk about the budget line, okay, just very quickly run through review this. About what the budget line is, just in case you forgot. Sometimes we forgot things very fast after that. Okay. Okay. So this is the budget line that you learned in intro. Right, so like all the budget line is just the name of a straight line. Right, so all straight line, to draw a straight line, how many points do you need? 2 points, right? So normally for econs, the 2 points we choose will be one here and one here. Right? So how do we get this point? Now on the vertical axis, how come this number is this? On the vertical axis, how come this is this? Because on the vertical axis, x is how much? X is 0. Now if you are buying 0 units of x, since the budget line shows the maximum quantity of two things you can have, right? The maximum quantity of two things you can have. So when your x equals 0, what's the maximum quantity of y you can have? You take your entire income, I0 divided by PY0. Remember? So it's the same. The reason why we don't put I0 here, because in every income we don't write as I0, we call as what? M, money income. Remember? So if what you have done in intro is the same, alright. Can you still remember your intro? You cannot remember that way. Luckily I still remember some. Some mean but not all. Not all. I told you I'm very good. So this one we used to call I0, PY0, but any income is called money income, so M over PY0. Right? Now the other point here is this, on the horizontal axis. Why this number is this? Because on the horizontal axis, how many Y are you buying? 0. If you are buying 0, what was the maximum quantity of X you can buy? You take your entire income I0 divided by PX0. Right? In this case, the income is not M, so M over PX0. Okay, so that's how we get 2 points. That's how we get the budget line. You join the 2 points, you get a straight line. In high class, this is called the budget line. Right? It shows the maximum quantity of two things this person either can buy. Now, what's the slope of the divided line equal to? Slope equal to opposite over adjacent, right? So if you take this opposite divided by this adjacent, what do you get? M over Py divided by M over Px, you get Px over Py. So we use this all the time, right? The slope of the divided line is equal to the price of the two things. The price of the two things. Here the thing is called root y root x, so it's the price of x over the price of y. So, can you consume outside the divided line? No, maximum on the divided line, right? So what's the equation of this line in mathematics? What's the equation of this line in math? The equation of this line. Now, you know that this line shows the maximum quantity of x and y in y, right? And so therefore, if you take x times the price of x, what do you get? Your total spending on x, right? The total amount of money you spend on x. If you take y times the price of y, what do you get? This will give you your total amount of money you spend on y. Y, right? Y is a variable. So if you buy 10 units of y times the price of y, this will give you a total amount of money you spend on y. Now, normally, our total spending on x plus our total spending on y, is it more than income or less than income? Your macroeconomics in your life, do you consume all your money, your income? You save some run, so therefore it's always less than your income. But income in here is defined as what? M. Okay, but this is wrong here. Why? Why wrong? Because it should be equal to your income. Why? The definition of the divided line is what? It shows the maximum quantity of two things you can buy, right? It also means if you have some loose change, what will you do? You will continue to spend up to the maximum. You use up all your income. Okay? So that means the total spending equal to the total income. So that is the equation of this line. Okay? Now, after you draw your budget line, so if this person's utility curve is, if x and y are the best substitute, what will happen then? First, what's this slope here? Px over Py equal to what? Can you understand why it's 1.5? Understand why? Because in this question you are told that the price of x is, the price of y is $1. The price of x is 150. And therefore Px over Py is 1.5. It means in mathematics this number, this here is 1.5. Yeah. Okay. Now we are given this person utility function, Rodney. Now Rodney utility function is okay, before I go further, this utility function is what shape? Convex or straight line? It's a linear curve, right? It's a linear function. Right now, if you rewrite this function, if you have to draw this function, you have to draw it. Then you have to postulate it in what? You have to draw this here. You have to postulate this function in terms of what? This versus this, right? Okay, so you rewrite, therefore it's this. This is a straight line. The vertical variable is this. The vertical intercept is u. The gradient is -1. The horizontal variable is x. Right. That means if you were to draw the utility function here, superimpose here will be this. The slope is how much? 1. Okay, so it's flatter than the divided line. Right. Namely because for this example, the slope here, this one is 1.5. 1.5, right? And this one is 1, so it's flatter. So y equal to u0. On the same line, the utility on the same line, u0 minus 1 times. You see? Okay, so I superimpose the utility function here. And so I can now find out where's the pendulum. Which point, which optimum That's the optimal bundle. This consumer will choose where to consume. You can choose any point on the bundle line. Where will he choose? Which bundle? Will he choose this bundle? Well, if he chooses this bundle here, his utility is how much? U0. Do you think this is the best bundle? Here better. Because if we choose here, your utility is higher or lower? Higher. You choose here, this point. This point will be on this utility curve. Which is further out, parallel, and trace here. Is this the best? Maybe improved. Yes, then where? Here better. See? Here, the utility is even higher. Well, if I choose this point on the boundary line, I think this is still not good enough. I think this is better. The boundary line is the highest. Right. So therefore, here. So you can see if the utility curve is a straight line, the optimal solution is a corner solution. Here. It means this guy will choose this bundle. Why? Because this bundle on the boundary line give him the highest utility. Okay? So you do not end up with two roots. You end up with an optimal bundle which is found at the corner. So therefore, for Rodney, what will be demand for X and Y? So what's Rodney demand for X and Y? Here means X equal 0, Y equal M is given as how much? The price of Y was given as 1. M was given as how much? Yes. So if you take 600 divided by 1, so its demand for Y is this. So we have a corner solution. Yeah. Any question? Now, if the two goods are not perfect sum,